Okay, this week we're going to be doing the chi-squared distribution and non-parametric hypothesis tests. This week it's a little bit different. A parametric hypothesis test is a hypothesis about a population parameter, and that's like the mean or a proportion. And up till now, this is what we've been doing. This week we're going to do non-parametric test, which does not involve a hypothesis for a mean or a proportion, but something different. And we're going to be using the chi-squared probability distribution. And the first test is the goodness of fit test. How well does an observed distribution of values fit an expected distribution? For example, we might see, do the sample data that I observe come from a population that's normally distributed? The problem that I'm going to do, one time I got a gift of a die from a casino, only this die had a hole drilled through the middle of it. And my question was, is this still a fair die? So what I did was I flipped the die 144 times and I recorded the values that occurred. So I got 12 ones, 18 twos, 24 threes, so on and so forth. And my question was, if this die was a fair die, could I possibly get a distribution of rolls that looked like that? Well, step one is the null hypothesis you see is going to be different. We're going to make a hypothesis about a distribution. The distribution of rolls is a uniform distribution, and that would be the same number of rolls in each cell. And the alternative is that the distribution is not uniform. The chi-squared distribution, you're only going to have one-tailed tests. In this case, you're going to find the chi-squared table with a level of significance of 0.05. Now, the chi-squared distribution changes its shapes depending on the size of the degrees of freedom. In this case, it's the number of degrees of freedom is the number of classes minus 1. In this case, we have 5 classes minus 1, or 6 classes minus 1 of our table gives you 5. The critical chi-squared is 11.070. Pause the tape and see if you can find that in the back of your textbook. To calculate chi-squared, we have to find an expected distribution. What if the die was perfectly fair? What would we expect? Well, out of 144 rolls, we would expect to get 24 in each category, the same number. Now, because we're dealing with a random variable, we really don't expect to get 24, but it shouldn't be that far off. Now, the way we're going to compute chi-square, we're going to take each observed frequency minus the expected frequency. We're going to square those, divided by the expected, add them together. So this slide is the computation of chi-squared. For example, the observed rolls was 12, the expected 24. 12 minus 24 is negative 12. Squared is 144. 144 divided by 24 gives you 6. And I did that same procedure. 18 minus 24 is negative 6. Squared is a positive 36. Divided by 24 is 1.5. When I do that for each cell in the distribution, I end up with a calculated chi-square of 15. When I compare my calculated chi-square of 15 to my critical chi-square of 11.070, I find that I would reject the null and accept the alternative. And my conclusion in this case is that the distribution of rolls of this die is not uniform. Therefore, the die is not a fair die.